we're going to be going over greatest common factors. What does greatest mean? Yes. The largest, the biggest. What does common mean?
You get it over and over.
Similar. And we know what factors are. So the greatest things that are similar for a bunch of factors. And that's actually a problem we did. That was number 3. So problem number 3 is what we're going over here. Now you saw how we did that, yeah? We just drew all that out, wrote all the factors down. You don't need to do that. Because numbers like, what were those numbers?
1,000,001.
No. Number 3.
96 and 30.
So we got 30 and 96. No, it was 60, wasn't it?
Oh, 6. I don't know. Oh, wait.
So 60 and 96. And then we did all that work, and what was the biggest one in that whole list? 12, I think it was.
Yeah.
It's like, oh my, that was a lot of writing we had to do. And, well, I don't want to have to deal with all that. And why do we even need greatest common factor? That sounds like the stupidest thing we need to know. I said stupid. Shh. Like, why do we need greatest common factor?
We don't.
Actually, we do. Here's one simple little example in everyday life that you'll need greatest common factor. Basically, if you want to make sure you can divide things out evenly, you have a bunch of stuff, and you want to divide it evenly among people. For example, you have a party, and you have so many water bottles, so many pencils, and so many calculators, and you want to make sure everyone gets an equal amount. You need to know your greatest common factor. So for example, I have a party, and I have 60 bags of Cheetos, and I have 96 cans of Mountain Dew Code Red.
Oh my God.
Now, I want to make sure everyone at my party that I invite has an equal amount. My question is this: how many people should I invite? Well, if I invite 60 people will get the Code Red, but there's an extra 36 left over, and I can't give those extra 36 to some of them. So this is what you do. You just find the greatest common factor. Now you can write them all out like you did here. So we'll do that the long way like we did for homework. The factors of 60, 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7 times nothing, 8 times nothing, 9, and there's already 10, so I'm all set. Now for 96, 1 times 96, 2 times 48, 3 times 32, 4 times 24, right? Yeah? 5, no, 6 times 16. 7 times nothing, 8 times 12, 9 times nothing, 10 times nothing, 11 times nothing, and there's 12. Now you look at this and you look at this whole list, you see what is the biggest one? So we looked at all the common ones and we circled 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 no, 6 and 6, 10 no, 12. Oh, it looks like that's it. That's our greatest common factor. Look at all that wonderful work. So that means I can invite 12 peoples to my party. All right. So I can invite 12 people to my party, and every single one of them will have multiple bags of Cheetos and multiple cans of Mountain Dew Code Red. It's wonderful, right? Now, but look at all this stuff I had to write down. It's a lot of work. I want you to see this over here. I'm going to have my 60 people. I'm sorry, not 60 people. 60 bags of Cheetos and my 96 cans of Code Red. And I don't want to write all that stuff because I don't have a lot of marker ink or pencil or pen. So this is what you do. This is a beautiful thing. You can just divide these guys by the same numbers. It's like reducing a fraction, really. And I'm going to divide it going down. What number goes into 60 and 96? Yeah.
1.
Yeah, but I can't divide it with a 1. Yes.
4?
Yeah, let's try 4. 4 goes into 60 15 times. How many times does 4 go into 96? I think it's 24. I'm not sure. Check the board over there. Yes, it is. Now I just asked myself this. Can I reduce 15 and 24? What can I reduce 15 and 24 with? Yes, ma'am. 3. I can divide 15 by 3 to get 5. I can divide 24 by 3 to get 8. What can I reduce 5 and 8 with? 2 can't go into 5. 5 can't go into 8.
It's 28 on the other board.
Yeah, I know. Wait, for 3, 96 divided by 3? Oh,
Oh, I thought it was
3, 6, with 3 left over. 3.
Oh, we have 48.
Oh, wait a minute. Oh, I'm dividing 4. 4 goes into 9 twice with 1 left over. 4 goes into 16 4 times. Yep, 24. Sorry. Failure. All right. What can I reduce 5 and 8 with? Yes.
12.
Nope. That's a 5. How can you reduce it with 12? I'm giving you a demerit for that. All right. Nothing. I can't reduce it anymore. I'm done. Now, guess what all I have to do? Just multiply those. What's 3 times 4? 3 times 4 equals 12. So a nice thing you can do to find your greatest common factor, just list your numbers and just divide both of them by the same thing and just keep dividing until you can't divide them both anymore. Shazam. Instead of writing all that out, you wrote down 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. There, I had to write so many numbers over there. Yes, ma'am. So basically, you list out your numbers like that and just keep reducing them until you can't reduce them both anymore. And then multiply by these numbers that you divided by. And that gives you your least common multiple. I'm sorry, greatest common factor. You can do that, and the beautiful thing is, you can do this with many numbers. Let's say I have 36 Snickers bars. I have 24 jalapeno cheddar Cheetos. Let's say I have 144 Pixie Sticks. And I have 96 Dark Knight Blu-rays that I want to give out to my party. Now, I don't want to list all the factors for these, and all of these, and all of these, and all of these, and then circle them and find the biggest one. I'm just going to divide them all out and say, what number goes into all of these guys?
3.
See, 12 goes into 36. Well, 1 isn't going to reduce anything.
4.
Well, there's so many numbers, so you really don't know, so I'm just going to pick, they're all even. So I'm just going to use 2 for right now. Actually, hold on. I can divide them all by 2, and I can divide them all by 3. The rule for 3 is just add up the digits. 3 plus 6 is?
9.
So I can divide it by 3 because I can divide 9 by 3. What's 4 plus 2?
6.
6. I can divide 6 by 3, so I can divide this by 3. What's 4 plus 4 plus 1? 9. Oh, what's 9 plus 6?
No.
9 plus 6 is 15. So I can divide all these numbers by 3, and I can divide them all by 2. Guess what 3 times 2 is?
6.
So I can divide it by 6. So that's the rule for 6. If you can divide it by 3 and you can divide it by 2, then you can divide it by 6. 6 goes into 36 6 times. 6 goes into 24 4 times. 6 goes into 14 how many times? 2. With 2 left over. 6 goes into 24 4 times. We already said that over here. 6 goes into 9 how many times? 1. What can I divide all these numbers by? Yes. I can divide them all by 2. 3, 2, 12, ocho. Oh, guess what? I can't reduce to these anymore, can I? I can do 3, 12, well, just 3 and 12, but I can't do the others. I can do 2 and 12 and 8, but I can't do that 3. So I'm set. All I need to do is multiply those. What's 6 times 2?
12.
So again, in this party where I have all this stuff, I can still only invite 12 people. So that way they can get all these things distributed evenly. There won't be anything left over. With these 36 Snickers, these 24 jalapeno cheddars, these 144 Pixie Sticks, and these 96 Dark Knight Blu-rays. They'll be distributed evenly among all these 12 people. They might have more than one Dark Knight Blu-ray, but then you can sell it to someone. Yes?
What if, like, for the Snickers, the person, like, is allergic to chocolate or something?
Well, then that one person will die. So, sorry. So I'll make sure, I'll just say there's no peanut allergy people allowed. So, no, just kidding. So that's Gray's common factor. You just line them all up and just keep reducing them all by the same number. When you can't reduce it anymore, just multiply by these guys, and that's your Gray's common factor. You can do the factor trees, but that takes so much time. I hate doing those factor trees. Hi. If you like this video, please watch this one. You might be interested in it. Or if you want to see my last video, right over here. If you'd like to subscribe, you can hit this little circle right about here.